All right, so we are going to talk about compound and continuous interest. So we've already seen our compound interest formula. Remember that in business math, they tend to go with the M instead of the N for the number of compounding periods. This is equal to the principal times 1 plus I. So I is equal to R over M, and N is equal to M times T. So I put that there where I is equal to R over M and N equals MT. So it depends on what you're given in your homework to which formula you're going to use. That is the compound interest. The continuous interest is A equals PE to the RT. Remember when we're doing continuously, we use the E formula. All right, so let's go look at some problems and then we'll come back and look at what's left on there. All right, so we are in 3.2 if you're in my class. And for example 1, we are going to find the future value, which is A. That's the amount in the account given. That P is equal to 3,000, I equals 0.09, and N equals 35. So if I'm looking at what I'm given, I have to choose the formula that works. I have P, I, and N, so I'm going to use this formula. I'm not going to use that one because I've already, they mean the same thing, but those are the values you're giving. So we're going to have A equals P times 1 plus I raised to the N power. So our A will be equal to 3,000 times 1 plus 0.09 raised to the 35th power. Put that in your calculator, you will get $61,241.90. Again, dollar signs go at the front. All right, let's look at example 2. And I can show you real quick. You're like, oh, can you show me how to do that? All right, so we're going to type in our 3,000, parenthesis, 1 plus 0.09, close your parenthesis, use your rooftop key, the correct key, raise it to the 35, and then hit enter. And again, you're going to go to 2 decimal places. The 3 after the 0 will not cause it to round up, so you are done. All right, let's go to example 2. We're going to find the present value given that A equals 3,000, I equals 0.11, and N equals to 120. So again, we have the same type of situation we have here, except in this case, we're given the A and we want to find the P. I find it useful if you write the formula each time. It helps you recall them a little bit better. Formulas, again, are given on the exam, but you become more familiar with them. All right, and that's 30,000, not 3,000. Makes a big difference. All right, so we have 30,000 equals to P times 1 plus 0.11 raised to the 120. So I'm going to combine my like terms here. So 30,000 equals P times 1.11 raised to the 120. I'm going to leave it like that and just divide by it. Because right now it's a manageable number to show that division. So when we put that in the calculator, we'll have 3 divided by 1.11 raised to the 120. You'll get 0.109. So 0.109 equals to P. Well, you're like, well, that looks like an interest rate. It is not an interest rate. That is how much they put in the account. So our P is equal to 0.11 and that would be 11 cents. We're going to go to 2 decimal places because we're talking about money. So they put 11 cents in. Now, n equals to 120. They put it in for quite a while. And it is interesting. They put in 11 cents. And the I, which is your rate, divided by your how much it's compounded, also equaled that. That's just kind of random. But that means they had a pretty good rate and amount of time that they put it in. All right, let's look at example 3. So we're going to find the future value. And again, future value is going to be A, the amount in the account, given that P equals 4,000, R equals 4.35%, and T equals 5 years. And it's compounded continuously. So again, remember, continuously, we're going to use the E. So we're looking at the formula of A equals PE to the RT. So we're looking for our A. Our P is 4,000 times E to the 0.0435. Again, your rate always has to be in a decimal. And then T is 5. We'll put that into our calculator and get 4,971.86. So again, how do you put that in your calculator? Because this one's a little bit different. We're going to put our 4,000, do the second E to the X is what we're looking for, so the LN button, and that gets us our box on my calculator. You might have parentheses, and then we'll put 0.0435 times 5, and then hit enter. And we get 4,971.86. The one after the 6 tells us we do not round up, it just stays at a 6. All right, let's look at example 4. So for example 4, we're going to find our present value. And again, our present value is going to be P, and we are given A is equal to 7,700, R equals 8.34%, T equals 9 years, and we're also told compounded continuously. So again, if we're using continuously, we're using the formula with the E. So A equals PE to the RT. We're going to plug in our values again. So A is 7,700 equals to our P. We need to find E to the 0.0834, again as a decimal, and T is always done in years, and it's 9. So this will get us 7,700 equals P. I'm going to multiply this, so we get E to the 0.7506. So I multiplied my exponents to simplify it a little bit. And again, I'm going to divide by the E to the 0.7506. So 7,700 divided by that, E to the 0.7506 will get us $3,635.04 is equal to our P. All right, we're going to go on to example 5. So example 5, we are asked to find the time. So I'm actually going to switch pages, I think, because it'll take a little bit to do this one. So example 5, we're going to find time in years, which is T, given that A equals 81,000, P equals 59,871. R equals 9.3%. And we are compounded continuously. All right, so again we have A equals PE to the RT. So 81,000 is our A. Our P is 59,871. E to the decimal of 0.093 times T. T is what we're looking for. T is in our exponent. So we're going to need to, because we're using E, we're going to need to use the ln to use the power rule to bring that forward, and the ln and the E will undo each other. So I'm going to divide both sides by the 59,871. And I'm just going to leave it. I don't really like to turn that to a decimal. You don't want to round early. If we take 81,000 divided by 59,871, it gives me this really long decimal. If I just round it to like 1.35, it can change the answer. And then if you're doing your homework online, if you don't have it at the right decimal at the end, it's going to complain. So leave it as a fraction so that we can get a consistent answer. All right, so we're going to have 81,000 divided by 59,871 equal to e to the 0.093t. So again, we're going to bring in our ln on both sides. So the ln of 81,000 divided by 59,871 equals the ln of e to the 0.093t. Now, because we have the ln, I can use my power rule to bring that forward, plus the ln of e undoes each other, so we're just going to be left with the exponent. So we have the ln of 81,000 divided by 59,871 equals 0.093t. Divide both sides by the decimal. And so now we have t is equal to the ln of 81,000 divided by 59,871 divided by 0.093. So to put that in your calculator, you're going to have your ln of 81,000 divided by 59,871, close the parenthesis, and then divide by the 0.093. And you're going to get 3.25007. So we're going to do 3.25. And again, t is in years. All right, example 6 is on our handout. So for example 6, we're going to find the future value, which is, again, the amount in the account, and how much interest is earned, given that $900 is invested at 13% for 10 years. We're going to do it compounded annually. Annually happens once a year. Quarterly, that's 4 times in a year. And monthly, which is 12 times. And if you don't remember what those are, you can go back in the handout to the first page. And all of those were listed on page 1 at the bottom right. So you can have that available to you. All righty. So let's write what we found out in our problem. So for example 6, we were given a few things. So 900 is invested. So our P is 900. 13%, so R equals 13%, which again will be written as a decimal. For 10 years, that's our T. And then we will have different sorry, lost my thought process. Annually, M. M is going to change. That's the letter. It's like, okay, what letter is left? All right, so here's our formula. A equals P times 1 plus R over M raised to the MT. That's the formula we're using. We're trying to find our A, how much is in the account, but the M is going to change for each one. So the first one for A, our M is equal to annually, so it's going to be 1. So we're going to have A is equal to 900 times 1 plus 0.13 divided by 1 raised to the 1 times 10. We're plugging in all of our numbers, and we can just put this in the calculator, and we will get, you can simplify it if you want. You don't need to put the ones. So 900 times 1 plus 0.13 to the 10, because 1 times 10 is still 10, divided by 1, it's the same. So our accumulated value is 3,055.11. So that's how much is in the account. What else did it ask us? Let's go back and make sure. Find the future value and so find the future value and how much is in, how much interest is earned. So how much interest did we earn? So how do we figure that out? Well, the interest earned is going to be the amount in the account at the end minus the original amount we put into the account. And when we do the subtraction, we get, oops, I put a decimal place where it doesn't belong, so let me fix that, 2155.11. So we earned $2,155.11. All right, let's go do our next one. For part B, we're still using the same values, except it said that it was quarterly. So quarterly means our M will be equal to 4. So we're going to have A equals 900 times 1 plus 0.13 divided by 4 raised to the 4 times 10. Again, if you want to put this in your calculator as 40 instead of 4 times 10, you can certainly do that. That's an easy multiplication, and sometimes it makes it easier to put in the calculator. But when you put it in, you will get 3,234.78. So that is how much is in our account and how much interest was earned. Well, again, we're going to take our 3,234.78 and subtract out our $900, and we get 2,334.78. So that's how much interest we earned doing it quarterly. So we earned a little bit more interest when we changed to quarterly. All right, let's go to C. So C is monthly. So here our M will be equal to 12. So we're going to have A is equal to 900 times 1 plus 0.13 divided by 12. 12 times 10 is our raised to part. All right, so again, you could put in 120 for your exponent instead of the 12 times 10 if you want to. But when you put it in the calculator, you're going to get 3279.36 is the amount in the account. So the interest earned, again, will be our total in the account, still minus the $900, will get us $2,379.36. Now, so what we notice is that the more times it's compounded in the year, from once to 4 to 12, the more compounding, the more money we earn. also the more we will owe if we're paying like a creditor. All right. So now we're going to go look at some more notes. We've got APY, which is the annual percentage yield. The APY is equal to 1 plus R over M raised to the M minus 1. Or if it's continuously, it's going to be APY equals E to the R minus 1. All right, so that's the annual percentage yield. So we are going to example 7, and we want to know what is the APY for money that is invested at each rate. So we have a couple of problems here. So our first one for A, we are told 5% compounded quarterly. So because it's quarterly, we're going to be using the APY equals 1 plus R over M raised to the M and then minus 1. Because we have an M value of quarterly. So APY equals 1 plus 0.05, again it has to be a decimal, quarterly is 4, raised to the 4, and then minus 1. So again, we're going to put that in our calculator. So we're going to have parenthesis 1 plus 0.05, divide by 4, close the parenthesis, raise it up with that rooftop key to the 4. Now remember, you have to scroll over on I have a little button here, and then subtract the 1. Don't put the minus 1 up in the exponent. Or if you have the older TI 8384s, close the parenthesis before you do the subtraction of 1. We're going to go to 4 decimal places, so 0.0509, because the 4 will not cause it to round up. Actually, we'll go to 1 more. So we're going to do 5 decimal places. The 5 will cause the 4 to round, so it will be a 5. And then change that to a percentage by multiplying by 100 or moving it the decimal 2 places over. We'll get 5.095%. Okay. All right, let's look at B. B, we are given 4% compounded continuously. Again, continuously uses the E. So we're going to use APY equals E to the R minus 1. 4% is our only value. So it'll be E to the 0.04. This will be our APY. Minus 1. Again, you'll put that in the exponent and make sure you don't put the minus 1 in the exponent as well. You'll get 0.04081, which will be 4.081%. All right, number 8. This will be our last question for this section. How many years are required for an investment to double in value at the rate of 9% compounded continuously? So I've given you some clues here. Double means that your accumulated value would be 2 times the principal. Triple would be your accumulated value is 3 times the principal. Because if you look at this, you're like, well, they didn't give us enough stuff. They only gave us a rate and compounded continuously. They didn't give us a principal, and they didn't give us an accumulated value. So we can still do this because we know that double is going to be A equal to 2 times P. So this will be example 8. We know we were using PERT because it said continuously, so PE to the RT. So My p will stay the same as p. My a, because it was double, will be 2p. 2p equals p. E, the rate we were given is 9%, so 0.09, and we're looking at how many years, so the t. But you're like, we have a lot of variables. Well, if you recall, we need to get e by itself in order to bring our exponent down using the power rule. So we're going to divide both sides by p. 2p divided by p, the p's will cancel, and we're left with 2 equal to e to the 0.09t. So that took out some of our variables. Now we'll take the ln of both sides. So the ln of 2 equals the ln of e to the 0.09t. This allows us to use the power rule to bring our exponent out front, and the ln and the e undo each other. So now we have the ln of 2 equals 0.09t. Divide both sides by 0.09, and t will be equal to the ln of 2. I'm going to put parentheses because that's what it'll look like in your calculator, divided by 0.09, and we'll get 7.7 years.